as I told everybody in here, I always forget that. So it's good that my track record is very consistent. So next time I'm going to forget to hit the button too. But anyway, hopefully you're here for this presentation. If not, you can go and find another good one. This is me. I am a technical architect at Acquia. I work in a lot of infrastructure stuff, but kind of, if you know Acquia, we do a lot of different things. I'm in a partly obscure team that doesn't actually do a whole lot of Drupal work, but I do some Drupal work in my day-to-day. So, but this project is more of a passionate side project for me. Not something that we do much at Acquia. Don't worry, we're not running enterprise websites on Raspberry Pis. This picture here, yeah, after this presentation, I'm sorry for putting a very succulent picture of Raspberry Pi on the screen. This is not what we're talking about. If you came here for a cooking class on how to make some Kubernetes-driven Raspberry Pis to eat, that is not what we're going to go over. We're going to talk over the Raspberry Pi computer. And I heard a couple people say this before the presentation, but the one question that pretty much everyone universally asks after they get a Raspberry Pi is, what can I actually do with this thing? And they're cheap enough that a lot of us just buy them because we're techies, we're nerds, we like computing things, and they're really cool, and we might have seen a blog post of somebody doing something cool, so we're like, if I buy a Raspberry Pi, I'll do something cool too. But that doesn't always follow. How many people here have a Raspberry Pi? How many people here have it sitting in their drawer or shelf or somewhere? Okay, so it's pretty true. It's pretty universally true. So I'm a little crazy, and we're running Kubernetes at Acquia on a few different projects, and we're building very massive things using these big hulking servers. But I wanted to see, like, on the very, very opposite end of that spectrum, on the lowest class of machine, how well can I actually run Kubernetes, which is like a cloud scale for massive deployments type of thing? How well can it run on a cluster of Raspberry Pis? I've been toying around with these clusters for about 5 years now with Raspberry Pis, with a lot of different little projects that I do. And Kubernetes kind of caught my ear in 2016, 2017 when it started getting all the hot VC capital funding and things like that. Because anytime there's something new and cool looking in the infrastructure world, lots of dollars follow very quickly. I didn't do it for the money, but if anybody here wants to throw a few $1,000,000 my way to build the next Raspberry Pi hosted Kubernetes cluster service, I'm available to talk. So anyway, I wanted to go a little bit crazier and deeper than that, though. Not only do I want to run Kubernetes on these things, I want to run a heavyweight CMS that can run ambitious digital experiences on these Raspberry Pis. So I have kind of insane requirements here. And before I get into that part of it, though, there's a lot of people here who might not be that familiar with Kubernetes. Kubernetes is a very large ecosystem. It has a lot of different moving parts, but I wanted to distill it down to something that I can fit into a 30-minute presentation, which only has 28 minutes left. So, at a very basic level, let's take a typical mid to upper tier Drupal site. You're going to have a lot of different things you're going to run. You have to run Drupal, which is like Drupal. It might use PHP and Nginx, or it might use Apache with PHP built in, but something has to run Drupal itself. You also have to have a database, so MySQL or Postgres or some other database running. You might have Apache Solr for search to make your searches faster and better. You might have Elasticsearch. You might have a chat integration that runs with a Node.js app. You might have some sort of more advanced cron system, so an external cron schedule or something. If you have all these different things running, you might have a centralized logging dashboard that has to run for it. You might also have caching, so Redis or Memcache or something running. So a Drupal site requires a lot of things if you're going to run it at scale, or if you want to run it with high availability and the ability to not have downtime. And every application has varying requirements, but a lot of things require at least like a database in your application or something else. And you also have lots of servers nowadays. So most projects that I've been working on in the past 5 or 10 years have some level of either a service level agreement or high availability that they expect. And you can't get that with one server somewhere. There's a lot of projects that can run on one server. But for a lot of these other projects, we need more than one server, because if you run on one server and that server goes down, which happens very much, even in fancy cloud environments where servers are virtual and they can pop from host to host, your servers will go down. And when they go down, what happens? So nowadays we have lots of servers, and traditionally you'd have some sort of system, maybe you use configuration management or some bash scripts, where you cross your fingers and run a bunch of manual commands on servers, and you get those things running on those servers. But it's not super efficient, and when one of those servers goes down, you still have to do something and intervene to get the services that were running on it somewhere else. So at a very basic level, now this is not a technical definition of all that Kubernetes does, but on a very basic level, it puts your stuff on servers. So you have servers, you have stuff. You get your stuff on the servers, and then it also makes sure that they keep running the way that you want them to run. So I'll show you a little bit more about that in a minute. But you might be a little skeptical at this point. You might be wondering, so you're building this Kubernetes cluster. Kubernetes sounds kind of complicated. If it's doing scheduling stuff, scheduling is always hard no matter what you're doing. You're running Drupal, which is kind of a heavyweight CMS. It requires a lot of RAM and all this stuff. So you must be building some sort of large community website or some big ambitious digital experience, right? Well, no, I'm actually running pretty much a static HTML website inside of Drupal. And you might now be thinking, OMG, WTF, BBQ, isn't it something like this? And this is a picture I found. I found it on Twitter while I was working on this presentation. If you can't see it very well, it's a large flatbed 18-wheeler truck, and there's basically a brick tied down in the middle of it. So a lot of times we infrastructure people and software developers are what I call architecture nuts. We want to build the fanciest, most exotic limousine to host a little teeny tiny thing that is almost insignificant. However, it is a good learning opportunity. And so the point I want to make about all that is it doesn't always have to make sense. For me, it's more of a fun, passionate side project. And really, what I have gotten out of it a few times in the past is you find things when you operate on a very small scale. When I have 4 nodes and they're physical Pis and they're using NFS, and they use the same software, but they're running on very slow hardware with slow networking and slow disk I/O, you run into some of the limitations very quickly, and you learn how to solve them on a small scale. And then when you get hit by the same kind of a bug on a larger scale, you can kind of know how that is going to impact you. You can plan for it. You can already have ways to mitigate it. So I have learned a few things. At least that's what I keep telling myself to justify buying 4 or 5 new Raspberry Pis every year. And on that topic, so a couple of years ago I was like, hey, the Raspberry Pi Zero is so cool. It's even smaller. And it was cool. I had an idea that I would have this cluster using Wi-Fi. The newest ones actually have Wi-Fi chips built into them, so you didn't even have to have a little dongle like that. But I would have Wi-Fi, and I would have a little battery pack. I could have the cluster in my pocket, and during the presentation I could whip it out and be like, look, this is running this whole thing. The problem is the Raspberry Pi Zero has the slowest processor ever made, well, ever made in the past 15 or 20 years of all the Raspberry Pis, I should say. And it's still a lot faster than the thing that put us on the moon. But it's very slow, and it only has half the memory that the Raspberry Pi 2 and 3 have, so you can't actually install Kubernetes on it. So that was very short-lived. It also got very hot, so I was fearful that before the presentation started I might be on fire. So I ran with another cluster that had 5 Raspberry Pi 2s, and you might notice that this new model that's in front of you today does not have 5, it only has 4. And the maxim, of course, with that flatbed truck is more is always better. The problem here is that more is better. When you hit the 5th Pi, though, you start having to buy larger power over Ethernet switches and more device things to go with it. So the scale, there's kind of a wall I hit at 4 with this new 2019 version. If you're wondering the parts that I use, any of that kind of stuff, there's a website, pidramble.com. It's actually running on a Raspberry Pi, a single Pi in this case, on my desk at home. Please don't hack into it. If you do, don't do anything too bad, because I'm not home, so I can't fix any problems that you cause. But anyway, it's running on one Pi at home, and it's been up since 2014. So what is that? 4.5 years. with 99.6% uptime. I'm pretty proud of that because almost all of that downtime was due to my wonderful ISP spectrum having very poor service sometimes. Anyway, so this is the new version of the cluster. And one thing that some people wonder a lot is, like, what is the best way to put Kubernetes on a Raspberry Pi? Some people wonder, wait, you can put Kubernetes on a Raspberry Pi? There's a really cool thing, I forget the guy's name, but I think he's in college now or something like that. There was a guy who was like, I want to get Kubernetes on this Pi. And he spent a lot of time working in the Kubernetes community to make sure that all the things that they built were ARM compatible. Raspberry Pis use a different type of processor architecture than most other computers, the Intel AMD 64 chip. So he spent a lot of time making sure that all the binaries and everything was built to run correctly on the Raspberry Pi. And since about, I think it was Kubernetes 1.9 or 1.10 or something, it actually works pretty darn well on a Raspberry Pi. So that's cool. So if you search online for how do I install Kubernetes on a Pi, you're going to end up on like medium.com, and there's these blog posts. They're 3,000, 4,000 words, hundreds of instructions, all kinds of stuff to do. And the problem is you kind of start getting tired. If you do that once and then you have to do it again, you start getting tired of having to do that over again, and then you start kind of burning out on it. Luckily for you, everything that I've done here is open source and is in code, and I've chosen to use Ansible to do it all because Ansible is what I call configuration management for humans and cows. That little cow down there, that is from the cowsay command line utility. Ansible has an Easter egg that if you install cowsay on your computer, it will wrap every command output in Ansible in a little cow. And you can customize the cow that you get and all that kind of stuff. But anyway, a cool thing about Ansible is it uses YAML as its language, or as its syntax. A cool thing about that is Kubernetes uses YAML for its syntax. Drupal uses YAML for its configuration syntax. A lot of different tools are standardizing on using YAML for kind of a human-readable way of configuring things. And once you know the basics of YAML and start getting into how to do things a little deeper, you can start seeing it. It's kind of like if you know English, well, English is a very bad language to compare with, but like Spanish or French, or what are they, Romance languages, or whatever that type of language is. If you know one of them, you start seeing the patterns in the other ones. So that's a cool thing about Ansible, Kubernetes, Drupal, a lot of different software. Now Symfony is using a lot of YAML everywhere. Anyway, so that's how I get it on there. Like I said, pidramble.com, I have a link to literally everything about this thing. And I want to get into a little demo. Lucky for you, this presentation is the first one where I'm bringing my little camera. I just thought of like, what, people can never see the thing, like in the back over there. Can you see everything up here? Probably not. You can kind of see a blob of green, but on the screen you can kind of see it. The other cool thing is I can actually say hello to the people on the web. Hello, people on the web who are viewing this on another day. So I've never been able to do that before. I mean, Kevin is awesome and gets all his recordings, but he doesn't have a full video production crew. So here's my video production crew. Glad to have them with me. So anyway, I have this picture up here. Let me see how I'm doing on time. Pretty good, pretty good. So I am going to, you're not supposed to see this. I'm supposed to act like I don't have a script and I've just memorized all this stuff completely and just dump it out of my hands, but that's not how I am. I end up Googling my own blog posts about 3 times a day, so. Let me hide that. And I'm going to first use Ansible just to give you a really brief overview of how Ansible can interact with multiple servers. And a lot of people also ask, like, why are you using Ansible? You're using Kubernetes. Kubernetes does all the hard work. Well, have you ever had to upgrade your servers? Have you ever had to configure your servers? Have you ever needed to set up firewalls? Have you ever needed to integrate your servers with other things? Or have you ever had to integrate 2 services with each other? On top of that, how did you install Kubernetes? How do you update Kubernetes? How do you manage the Kubernetes configuration files? There's 101 different ways to do that kind of thing nowadays. But there's not a lot of ways that are as mature or as flexible as Ansible. And so that's kind of why I still stick with it for a lot of the different things I do. On top of that, Kubernetes is a container-first solution, whether it's Docker or some other container technology. How are you building your images? How are you scanning your images for vulnerabilities? How are you distributing your images? Are you managing an image repository? All these different things still have to be automated, configured, set up. Even if you're using cloud services, how are you integrating all that together? And do you have one code base where you can literally set everything up? If you use Ansible, you can actually say the answer is yes. I have a code base where I run a few commands, and literally everything comes from nothing. It's pretty cool, playing God like that. So anyway, here's Ansible. I'm in a folder. This is the Raspberry Pi Dramble project. Like I said, it's on GitHub. You can clone this and build your own little cluster if you want. You can even build it locally on your computer if you don't have the Pis. And even if you only have one Pi, you can run Drupal on it. I have another project called Drupal Pi. And I'll talk a tiny bit more about that later. But I'm going to use the Ansible command line. There's a lot of different ways you can use Ansible. This is one of them, to just remote control a bunch of servers. Inventory. The inventory file tells Ansible about the servers, so in this case I just give it the IP addresses of all the servers. And then I say I want to operate on all the Pis, and I'm going to use Ansible's service module, which lets me control things running on the Pi. And I'm going to give it some arguments. I'm going to say, for the service, Dramble node monitor, I want to put it into a state of stopped. That means basically stop the service. Right now you'll notice that all the lights on here are green. That's because I have a service running on the Pis that's constantly monitoring the health of each of the Kubernetes nodes. And if one of them goes bad, it'll turn red. If it comes back, it'll turn green again. So I'm going to stop that for now because I want to show you how Ansible can remote control everything. When I stop it, it'll connect to all the Pis, and they should all shut off. There they go. And then I can show you if I say Ansible-I inventory all-a. If you don't provide a module on the command line, it just uses the command module, which literally runs the command that you give it on the Pis. So I'm going to say blink stick. These little LED boards are called blink sticks, by the way. Cool little project from a guy in the UK. He has a lot of different remote control LED boards for maker type computers. So blink stick blue. And the -B flag means run it as Pseudo. You have to have super user or root privileges to control the USB hardware on the Pi, so that's why I have to do that. So you can see how quick it is to make changes. Let's turn them green. It takes maybe a second or two. But with Ansible, you can also have a lot more control over how the rollout happens. So a lot of times, like if you're upgrading Kubernetes, or if you're upgrading the Drupal container or something like that, on multiple servers, you don't want to do them all at once and then they all fail right away. You want to like do one, if it worked, do the next, that kind of thing. So you can control this stuff. Let me go back, it's green, so I want to go to blue. You can control this stuff with forks, or Ansible also calls it serial. You can do it serially in groups of like 1, 2, 3, or however many you want at a time. So I'm going to do forks equals 1. And you'll see now it's doing it 1, 2, 3, 4, like that. And let's turn it back to red this time. I don't know if you're colorblind, can you see blue-green differences? Okay. All right, good. So you can see red too, hopefully. So they're all turning red and stuff. So that's just a quick overview of what Ansible can do. When you're installing Kubernetes, there's a few orchestration pieces, like you have to get a token from the master server and then use it on the other servers, things like that, that make it helpful to be able to run a command one place and then use the data from it to go to other places, that kind of thing. And the playbook I have does all that for you, but if you want to find out how it's done, just go into the source code and take a look. So I'm going to turn back on that node monitor. So I'm just going to change this service from stopped to started. And it should switch them all back to green if they're healthy, of course. And they are. All right, so the next thing I'm going to do is demonstrate one of Kubernetes' coolest features. It's the ability to self-heal. Basically, it sees there's a failure somewhere, and then it just kind of is like, okay, I'm going to react, and I'm going to move things around. That way I don't have to wake up Jeff in the middle of the night. So I'm going to check really quick. Kubernetes has a command line utility called kubecontrol or kubectl that lets you interact with your clusters. So I'm going to say kubecontrol get pods. Now, I'm going to mention this later. You need a dictionary when you're working with Kubernetes. Pods are containers. That's not a technical definition, and don't memorize that. But for the purposes of this presentation, a pod is a container or an application running on a Pi. So I'm going to say, tell me about all the pods that are running on all namespaces. I'm not going to get into namespaces. Unfortunately, we only have 10 minutes. So I'm going to get all the pods that are running on the cluster. So you can see there's some Drupal pods. There's a database in Drupal. There's some networking pods. There's a proxy. There's a thing that's a load balancer, Trafic. It's kind of like Nginx or HA proxy, but it's a little more cloud native-y or whatever. But it runs really well on the Pi. That's why I chose it. And you can see that they're all running. So I'm going to say git pods, and I'm just going to look at the Drupal ones for now. And then I'm also going to say wide. That lets me see what node that they're running on. So I can see Drupal's running on Cube 2, and MySQL's running on Cube 3. And so I'm going to take down Cube 2 really quick and see what happens. First of all, here's the site that it's serving. I'm not connected to the internet. This is running locally. And the Pi is connected by a network cable to my computer. So I'm loading these all off the Pi. And if I say SSH Pi at, 10.0.100.62, and then I'm going to say, I could do this with Ansible, but for the purpose of this presentation, I'm just doing this by hand. System control stop Cubelet. Cubelet is the service that manages Kubernetes stuff per node. So I'm going to stop that, and you should see that was pretty quick. It turns it red because the node is unhealthy. If I go over here, I can say kube control get nodes, and that's going to tell me about the nodes in the cluster. So you can see it still thinks they're ready. That's because Kubernetes has timeouts. It always kind of has like grace periods, and it has back off and things like that, so you don't end up killing yourself by like flipping something on and off a lot. So it should realize within 30 to 40 seconds that that node is actually not healthy, and it's going to switch it from ready to not ready. And meanwhile, that pod is still running on that node, and if you were still connected to that node, you would still be getting requests and things, but a lot of times, like in Amazon or in Azure or whatever cloud that you operate in, even if it's a private data center, networking routes just go bad. You can see that it just marked it not ready. So at this point too, if I look here, it'll say that it's still running, and it thinks it's on Cube 2, but I'm going to watch this now so we can see it live update. And within a few seconds, it's going to say, hey, Cube 2 is unhealthy. I need to get a new pod running on a better node somewhere. And usually that happens 30 to 40 seconds. You can actually configure all these timeouts. But you can see now it marked that one to terminate. It says, I don't know if that node is even up, so I'm going to kill that container. It can't actually terminate it until that node comes back up, but it's marking it as I'm going to terminate this. But it already popped a new Drupal on Cube 4. So I'm going to go over here, and it's still loading fine. So Kubernetes just saved me a pager in the middle of the night because one of the servers went down, and it just kind of moved the stuff off of it that it needed to move. So I'm going to bring that node back up. And the light should turn green on here, which it did pretty quick. And at this point, Kubernetes should also mark that node as ready. Yeah, so it's a lot quicker about marking it as ready than it is not ready. I guess it wants to be safer, not like killing off your applications that are running. So let's see, I still have a few minutes, so I have time to go through my favorite part of this presentation. The next thing I want to show is how you can also scale up very easily, scale out, I should say. So Drupal is an application that if you have a lot of logged in users, or if you have a lot of traffic that you can't cache, like in Nginx or Varnish or something, it needs a lot of CPU. So a lot of times what happens is your servers get overloaded with CPU and you need to scale, but like with Amazon autoscaling groups, it can take minutes or lots of minutes to scale up. And there's different container engines, they can all do different things. With Kubernetes, it's really easy. You can configure something called HPA. And so I'm going to say watch kube control get HPA. Kube control also is pretty consistent. You get resources, you can describe them to get like all the data about them, you can add them, delete them, all that stuff through the command line. And Ansible also has ways to interact with all these different commands too. The API is very thorough and robust. So I'm going to do this -n Drupal, and this is going to show me, I already configured this HPA, horizontal pod autoscaling. It basically says I have a target of 50% CPU. You can configure based on CPU, memory, HTTP requests, like whatever metric you want. You can say when it hits this, scale up. And you can give it limits of how big it can scale and how quickly it scales down. So right now, it's not doing much because I'm just sitting here refreshing this page every now and then. That's not a lot of work for Drupal to do. But we're going to make Drupal, we're going to give Drupal a little workout here. There's no caching turned on, so this is going to hit Drupal pretty hard. Let's see. I'm going to use WRK, which is like Apache Bench, but a little easier to use for me. Let's see, -C5, so 5 connections. We're going to run this test for 120 seconds with 5 threads, and I'm going to call the front page of the site. So I'm going to start that running, and basically what that's doing is it's using 5 threads on my Mac just to hit the site as fast as it can. And Drupal's going to be serving as fast as it can too. So you can see it already reacted to my earlier when I was just refreshing the page that brought the CPU up to 2%. Pretty soon this is going to start going up more, and this is just Kubernetes will see that there's a lot of CPU being consumed by Drupal. And once it does that, it will start scaling up, and you'll see that this replica count will go up. So we'll give it another 30 seconds or so, and it should start seeing that target percentage go up. Again, with all these numbers, you can kind of set it to be more aggressive or more passive. I haven't seen if I can set it to be passive aggressive, but the servers themselves do that to me plenty. So you can see it just went up to 279 over 50. That's not a very healthy way for a container to be. So what it's doing now in the background, I could be showing you the other things showing like container creating, but it just created 2 more Drupal replicas, and it's going to spread them out on the nodes as much as it can so that it can get the requests distributed amongst the Pis. So if I show you get all the pods, you'll see that now there's 3 Drupal pods. There's one on Cube 2, one on Cube 3, one on Cube 4. So it automatically knows like I need to spread these out. I need a lot because I'm getting a lot of traffic. So that is the live demo portion. Thank you for actually working camera, and goodbye people on the web. Let me pop back over here. And so, yeah, okay. So how was it? You can see here that, you know, it's not the fastest thing in the world. It's not the slowest thing in the world either. There are plenty of production servers that I've seen that cannot serve as much authenticated traffic as this Pi cluster can. And if you scale up, the cool thing about this is, for some parts of it at least, and for some Drupal use cases, as you scale up, the numbers just keep going up. One thing that I have not solved very well yet is databases in Kubernetes. I'll mention that in a few minutes. But if you have a site that's cacheable, like a lot of anonymous traffic, and you use Nginx or Varnish or Cloudflare or something, you can handle thousands of requests per second, no sweat at all. And I actually have a configuration on that Drupal Pi project. You can use it as a load balancer in front of the Raspberry Pis with caching. And that's what I do at home when I have this at home. I have the little Raspberry Pi as my cache, and these Raspberry Pis do the traffic serving. Although I've not used them quite as much since I have fans on them, because the fans get a little annoying sometimes. A few caveats to doing what I do. If you want to run your own little data center at your house, you're going to have to deal with these things. You know, I've not met many people who have 3 or 4 redundant power supplies, backup generators, and whole house UPSs. There are a few people that do that kind of thing, but most people don't. You have to deal with networks. How many of you have 3 or 4 ISPs, and all of them are giving you like 10 gigabits or more bandwidth? Probably not many. Also, physical security. I don't know anybody that has a house where you have 5 or 6 layers of biometric security to get into your house. There are some people that do that, but not many. You know, you have to maintain the Pis, you have to upgrade them. What happens if you get a lot of traffic? At my house, when I get a lot of traffic, it actually makes my internet slow because I only have 10 megabits of upload bandwidth. So when you're downloading stuff from my Pi Dramble site, that's my upload bandwidth going away. That makes everything slow. Kubernetes itself, you know, I didn't get super deep into it. I just wanted to give you a little bit of a dip your toes in the waters here. But there's a lot of things that you have to consider if you're ever considering using Kubernetes or building on top of a service that's built on Kubernetes. There's a lot of things that are easy to shoot yourself in the foot over. It makes some things way easier and it makes some things better, but it's also still maturing, and it's still becoming kind of a new standard type thing. So a lot of the things you find online will quickly give you big security holes. You're going to need a dictionary. So I mentioned pods, kube control, RBAC, role-based access control, HPA, all these new terms. You have to learn what they mean, what they do, how to use them. And basically, done well, you can do really cool things. The projects I'm working on at Acquia, this little Raspberry Pi cluster, there's a lot of cool stuff you can do with Kubernetes, but if you do it the wrong way, I call it failure at web scale, because you're tempted to throw everything into Kubernetes. And if you have a major security hole, all of a sudden everything is exposed instead of just one thing. So be careful, be smart about where you might consider using it. So in the end, the big question, how well does Drupal 8 run on Kubernetes on a cluster of Raspberry Pis? Pretty well. I mean, this demo didn't fail. 2 demos ago that I gave of this cluster in an earlier version, my computer actually died in the middle of it. The Pi cluster was fine. I just didn't have a way to shut it down because my computer died. But it runs pretty well. I'll have the slides online so you can get to these things, but the different things I mentioned. I know you mentioned, Benji, that I have a book. I actually I'm terrible at marketing. So at the end of my presentation, here we go. I have little cards. This has a 25% discount on Ansible for DevOps, the book that I wrote. And it actually has a chapter on Kubernetes, and it has a chapter on Docker, both of which are very handy if you're going to be building this cluster. And I'm working on a new book, Ansible for Kubernetes. I figured that Ansible 4 is a good theme there. And the last couple slides, please give feedback on the session. So I'm almost exactly on time. Last night I was 1 minute over. Let's see if I can hit that again. And then also contribution day is coming up. Thank you.